Actually, they're excellent procrastinators. So don't procrastinate on these projects and done. This one is pretty challenging. Some of you are going to get stuck on figuring out how to do it. It's not long, but the algorithm is not obvious, and you have to figure out how to do it. I will mention, people keep asking me, we do expect you to write some instance variables of your own choosing for the class you're writing. Go ahead and pop in some private instance variables. You're always free to write private methods if you want. Just don't write anything public. So before you ask me, we are expecting you to write some instance variables that you choose to solve this project. Okay, anyway, if you haven't started the project yet, get going. All right, last class I started introducing abstract classes, and I didn't get to my example. Let me just sort of hit again the main points that I want you to know about it. So you can declare a class as abstract. The idea with an abstract class is it's not really a finished product. The abstract class is intended to be extended in various ways, and those extensions will be sort of concrete finished classes. The abstract class probably has some instance variables in there. Otherwise, you would just use an interface. So you probably have a class that has some real data in it, and some methods that involve the data in some fashion. And then you're likely to also see in the abstract class one or more abstract method prototypes. And that looks like, look at my slide here. I've got a thing called drawme. I'll show you the code in just a minute for this example. There'll be a prototype that says, public void abstract void drawme, and then a semicolon on the end, no code. Just like you see in an interface typically. It's a method prototype with no implementation. And the idea there is just like with an interface, if the shape class includes this abstract prototype called drawme, every class that extends the shape class is expected to actually write a drawme that works. It's sort of a requirement. If you extend the shape class, you must provide a drawme method. And now, what's the context? What am I doing here? I think I ran this the other day and didn't get very far, but if you run my example, it looks like this. I made a GUI. I'll show you the GUI in a minute. And it draws a whole bunch of randomly generated shapes on a rectangular panel. And I'll show you the code for it in a second. But in passing, let's tie this to the inheritance diagram here. Shape is an abstraction. All of these are shapes, but just knowing the thing is a shape doesn't really nail it down. The concrete classes are circle, square, and rectangle. Now let me show you a little bit of the GUI code here. I'm going to preface this with the following. I am not teaching you how to write GUIs today, but we'll get to a part of the course where I'll spend like a lecture or two on writing GUIs. It's kind of fun. Education is not only interesting, but it's kind of fun. So some of the code I'm about to show you, you don't know yet, but I want to show you the relevant parts that are about writing an abstract class. So here's my example. I called it a GUI is the class that actually draws the GUI. And note that my GUI class extends a class called JPanel. So this is really typical in Java programming. Some programmer a long time ago wrote a class called JPanel. When I'm making a GUI, I usually write a class that extends JPanel. So the JPanel class is already there. It's part of the Java graphics framework. It's a rectangular region. Usually it's embedded in a frame called a window. Right? So the panel is the thing you draw into. So I think it's a rectangular region. I'm going to draw in there. It's a panel. So almost always when I'm making a GUI, I start like this. I say, well, I'm going to make my customized panel. So you're sort of, every time, making a customized panel. So that's what this says to me. It says I'm making a customized panel. Now, if you look at my main method, it's going to confuse you pretty badly, because I used in there a thing called an anonymous inner class. We're learning that later this semester, soon actually, but not today. So skip over the main method, don't even look at it. But here's the list of shapes. Shape, not circle, square, rectangle. Just generally, I have a list of shapes. There's some code that usual stuff for a GUI, blah, blah, blah. Here I am populating the shapes array with some random shapes. You can look at that later on your own time. Here's what I want to focus on right this second and teach you a little bit about GUI development. The JPanel class, that's the rectangular region that's sort of embedded in a window, has a method called paint. And anytime it's time for Java to draw what's in the panel, it calls the paint method. And the paint method that's in the JPanel class does a whole bunch of stuff. Let's say that you have buttons in your panel, or pictures, or text, or editable boxes, all those widgets that you might put into a panel. The method in the JPanel class knows how to draw all that stuff. And so you don't have to write all that code. You just say, put this here, put this here, put this here, and it gets drawn sort of automatically. I don't have to write code to actually draw all that stuff. The JPanel method called paint does that for me. But sometimes I want to do some custom drawing of my own. So this is what we do. We override the paint method that I inherited from the JPanel class. Note that there's a parameter there of type graphics. And it's hard to explain what graphics means, but it's really short for graphical context. It's more specific than the word panel. A graphical context involves all kinds of stuff, like there might be a clipping region, and there might be some scaling involved, and there's probably a current color involved. There's some state to a graphical context. that isn't present in the panel itself. But anyway, so this method paint is what we override in order to do custom drawing. So the first thing you do is always call super.paint. Super.paint is going to draw all the usual stuff. If the panel has buttons, text, pictures, whatever, it draws all that stuff like it normally would. And then after that, you're free to do whatever the heck you want to customize this panel. And so if you're doing any custom graphics, this is almost always how it looks. So my custom graphics is go through all these shapes in that list, tell the graphical context to set its current color to the color of this shape, and then tell the shape to draw itself. So this is what the Draw Me is about. Each shape somehow knows how to draw itself. So in the circle class, let me go back to my slide now. Oops. In the circle class, I'll show you the code in a minute. There's code that draws a circle. And in the rectangle class, there's code that draws a rectangle, and so on. So the classes, the individual concrete classes that we can actually instantiate, new circle, new rectangle, those classes know how to draw their own shape. Now the reason this design appeals to me is that this code doesn't know in advance what the shapes are. This is critical to understanding why we hear about polymorphism, right? This says, there's this abstraction called a shape. It has some state, I understand. The shape has, let's look just to make sure we didn't miss this. The shape has X and Y coordinates and where it's sitting on the screen, that makes sense. It has a width, which is like its size. It has a color, I get that. So the shape has some state, but I really don't know what various shapes might exist. All I know is that the shape has to have the capacity to draw itself. Now that's enforced because this abstract class declares in abstract this method draw me, and that means that the subclasses have to provide code that actually draw themselves. So looking at this, you don't even know what the shapes are going to be. Let me say that a different way, maybe it'll help you to see what I'm saying. Let's say I finished this project with my squares, rectangles, and circles, and it's looking pretty good, and then somebody says, you know what, I'd like to see a triangle. No problem, I'll write a class called triangle that extends shape. I'll show you the shape class, most of the code is in there. All I have to do is tell the triangle how to draw itself, and it'll flow right with the existing code. So a polymorphism is really useful for adding components, and whoever's writing this code sort of has a general idea of what shapes are, and the only thing we're requiring is that the shape has to know how to draw itself, and then this will run. So we're free to add other shapes later on without doing a whole lot of work. We don't have to reprogram this whole framework in order to add components later that we haven't even anticipated yet. That's why we like polymorphism. Let's look at these classes, shape and so on. Are you guys kind of with me on what I'm talking about up here? So it says shape, it doesn't say what kind of shape. I don't know. Who knows what the shapes are going to be? You can add more in later, it'll still work. So let's look at the abstract class called shape first. It's just what was on my slide. It says abstract right there. Okay, that means you can't instantiate it. You can't say new shape. That's not going to happen. This is like, it's an old-fashioned word blank. This is a blank. It's not finished, it's sort of the starting point, and we're going to finish it up in those concrete classes, circle, square, rectangle, ones that extend this guy. But this is the starting point for all the shapes. They all share this code. They all have X and Y coordinates, they all have a color, they all have a width. Here's the color constructor, nothing interesting here, just a regular constructor. I wrote getters, nothing interesting here, just regular getters. There's the interesting part. This is the abstract method draw me. No code here, just the semicolon. Looks like an interface, right? This is where the abstract class and the interface intersect. Interfaces typically have lots of these abstract methods. Here's one in this abstract class. And again, this means if you write a class that extends this one, you have to provide a draw me that draws your shape. If you're a triangle, the draw me should draw a triangle. Notice I'm passing along the graphical context so that the person has like the environment handy. They can draw yourself on this context. That's what this says. And let's look at those classes next. How are we doing? Yeah.
When you're creating a function that basically the abstract method, is it technically overriding the method, or is it just making?
You call it an override. So when I'm into those other classes like circle, and I'm going to show you my draw me, you say it's an override. The word override, I agree with you, it doesn't really fit, but that's how we say it. With interfaces too. There's a method like this in an interface with no real code, and I implement it in my class. We say we're overriding it. It's kind of a misnomer. All right, so let's look at the circle. So circles can extend this guy. Circle inherits all this code, and since this is abstract in the superclass, I have to write draw me in the circle class. Here it comes. So class circle says at the top extends shape. All right, so we inherited all that code I just showed you, and now it's really easy to customize this thing into a circle. I need a constructor for circles, and it's X and Y coordinates, a color. I'm calling this diameter. Why is this a red mark right here? Oh, I screwed up my code. There we go. I don't know what keystroke I just hit, but it really fouled things up. All right, sorry about that. Anyway, I'm calling this diameter, but that's a circle-specific term that means width. So whatever. Here's the super class constructor. This is the shape class now that has the constructor I showed you guys. I'm expecting those parameters. So this is nothing interesting going on here, but the circle is constructed by relying on the code in the shape to do the assignments for the instance variables. So great. And now I just have to draw a circle. Here's the draw me. Well, guys, in this graphical context, this graphics class, if you look at the API, there are all kinds of methods in there. One of them draws an oval. There's no draw circle, which always disappoints me. I'm constantly wanting to draw circles, and you call it draw oval. But anyway, this is in there. It wants an x coordinate, a y coordinate. It wants a width and a height for the oval. Well, if it's a circle, the width and the height match. So I'm passing along the x, the y, and the width twice, and that's a circle. By the way, don't forget, I can't just pass the variable for the x coordinate here. Even though the class I'm looking at, circle, inherits that x coordinate, it's private in the shape class. Don't forget this is pretty standard. If you've extended a class, you inherit all the data, you can't touch it usually. So I can't just say x coordinate here. I have to call the public getter to get my hands on that x coordinate. Same with the rest. But anyway, this to me looks good. It's gonna, when the circle is told to draw itself on this graphical context, the circle says, no problem, I'm drawing myself on this graphical context, and I'm done. There you go. That's it. So the customization of the shape is really short. All of a sudden, this type of shape is a circle. The others are just as stupid. Let's look at rectangle. Are you guys following? All right, everybody's quiet today. Yep.
Yeah, in heat, does it look the same as when we extend it for a regular class?
So yes, so circle extends shape. If you think about what's on the heat, this circle object, somebody says new circle, or what do you get on the heat? You get a shape object that has x coordinate, y coordinate, color, and width, and then sort of attached to it would be any extra state that the circle has. This circle doesn't have any extra states. It's hard to sort of say how the picture looks, but you're right, the idea is that it really is a shape with some circle features kind of tacked on. All right, let's look at rectangle, which I guess is next in my plan. Same kind of thing, except a rectangle needs another piece of state. Like, a rectangle doesn't just have a width. A rectangle has a width and a height. They're not always the same, like with the circle. So I added height. So this rectangle has 5 instance variables. X coordinate, Y coordinate, color, width is already there. And I'm adding height. So this is an extra piece of data that a rectangle needs. And now my constructor has 5 arguments because there are 5 instance variables. When I call the superclass constructor, don't forget this is the shape constructor. It only wants 4 things. It wants the x, y, the color, and the width. And I'm managing the instance variable height here myself. So I know that for most of you this stuff is pretty new. But for me, this looks like really standard code for extending a class and adding one little detail. The constructor relies on the constructor from the superclass, and then you got to handle that one little detail you added yourself locally. That looks to me like totally standard stuff. Do you guys kind of get it? Okay. So that's my rectangle constructor. What about draw me? Well, good news. There's a rectangle drawing method in the graphical context. So the same as with circle, this one's even easier. There's a method in the graphics class called draw rectangle. It wants an x coordinate, a y coordinate, a width, and a height. I've got all that. Height is the local. I almost said local. That's wrong. The height is that extra bit of data that I added for rectangles specifically. So that's it. That's the whole thing. Easy, right? Once I've got that shape class written, customizing it into these concrete classes is pretty easy. Do you guys kind of appreciate the idea here? So you start with this abstract thing, shape. The shape isn't done. You don't know how to draw it because you don't know what it is. The word shape doesn't define how to draw something, right? So we have to be more specific later. I think it's a good place to use an abstract class. Let me next show you the square class. That'll finish things off. Here's a hint. Look at my diagram. Literally, I've written square is a rectangle. Right? Square is a rectangle sounds good to me. So the square inherits all the rectangle features. Oh, sorry guys, aspect ratio is on there. This morning I changed it to height. I'm sorry. So pretend that says height. But anyway, square extends rectangles, so square inherits all the rectangle features. Draw me will still work. The inherited draw me sounds pretty good. I just have to manage this height feature. How do I manage the height for a square? It should match up with the width, right? So this is going to be a no-brainer. I'm just going to write a constructor and call it a day. Look at this. Here's my square class. Done. So the square constructor wants the usual 4 things, x and y, color, and a width. That's enough. But since the superclass is rectangle, I have to use the constructor from the rectangle class that wanted 5 arguments. That's fine. X, Y, color, width, and for the height of the rectangle, I just use the same thing. It's a square. The height and the width match up. So this calls the constructor in the rectangle. It works great. And then when somebody calls draw me, I inherited draw me from the rectangle. Draws a rectangle that's shaped like this. Great, done. So that was easy. All right, so that's my example. I kind of like this example because it's pretty clean, and I think it illustrates why you might choose to use an abstract class. You guys get it? Real quick before we move on to other stuff, what is the advantage of an abstract class versus an interface? Instance variables. The abstract class can hold state, and also constructors and probably some related methods that manipulate that state. So the abstract class has all those features that get inherited from the subclasses. You can't do that with an interface. There's no state in an interface. It's just a description of some methods. What's the advantage of interfaces? Well, a class can implement as many interfaces as it wants. But when you say my class extends this particular abstract class, you lock that in. You only have one choice for what you're extending. It's a very sort of rigid decision to say, I'm going to extend this thing. Can't extend something else later. So we like to say implementing an interface is sort of a lightweight design, whereas extending a class is much more rigid. So if you don't need the state, write an interface. You know, it's usually a better idea, but I think this is a pretty good example that makes the case for an abstract class. All right, that's kind of the end of that part. How are we doing? You guys good? Your TA is going to go over another example in the lab on Monday, I think, that shows abstract classes and some other stuff that we've learned recently. It's kind of an elaborate example. They're just going to kind of go over it with you. So you'll see one more good example of an abstract class next week. All right. You guys good? All right, let's move on. I don't even remember what's next. I'm going to sleep up here. Oh yeah, this is the whole, I didn't realize this. The rest of the lecture is about exception handling. How could I have forgotten that since I just did this lecture twice? But anyway, this is another one of these topics where when we developed this course, we assumed all the incoming students have already seen exception handling, and so we could do a quick review. And just like with a few other topics, I'm realizing that some of you guys who maybe had an AP course in high school, maybe didn't see exception handling ever. So like before, I'm planning on posting some of my own lecture videos that I did over COVID from CMSC 131. I'm going to do a really quick review, which pretty much is from the ground up, but it's fast. So if you're still shaky on exception handling after this lecture, later on today I'll have posted those videos. Watch them. They're sort of a slower treatment of the same thing. I have like 2 full lectures instead of 25 minutes. You know, so anyway, let me do a crash course on exception handling, which we think is a review for most of you at least. So first of all, well, let me say this. What is an exception? Exception is short for exceptional event. So think it's sort of like something weird happened. Let me give you the context and some idea of what we're talking about here. Let's say you're writing a method, and when you write a method, there's a contract that's like what you're supposed to accomplish, right? So there's like instructions you're supposed to do, and you're like, I'm a good programmer, I know how to do this. You write your method, it's finished, it's correct, you're happy with it, life is good. But sometimes there might be a case for an event that it's not clear how you should proceed in your code. Something sort of like unspecified. Let me give you a really concrete example. Let's say you're writing a method, and your method is going to go over the internet to connect to a website and scrape some data off that website, do a computation of some kind, and return a number. I don't even know what I'm doing, but that's the idea. You're going to connect to a website, get some data, do some math, and return a number. That's your job. All right, after this course is over, by the way, you'll know how to do all that stuff. It's easy to connect to a website. I'll show you later. But let's say that's your job, and you know how to do it because you took 132, and you wrote a correct version of it. It works, you tested it, it's great. What should your code do in the case where the internet is down? The contract says return a number. You have to return a number. What? You can't get the data. How are you going to compute a number and return it? What do? There's no answer to that question. Somebody's hand is up. I don't know what to do. Well, actually, maybe you're thinking like I am. Exactly. What you're thinking is, since I don't know how to come up with a return value, I will do the modern thing, which is to throw an exception. In the old days, in a case like that, the code would be likely to return like an error code. And we still do this occasionally. So the contract would say, normally it computes a number, blah, 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 but if something bad happens and the method fails, it will return this special code that indicates failure. We still do it, C programmers still do that all the time. Sometimes I do it, but that's not so great because it relies on somebody to read your instructions and to implement a case and all kinds of stuff that's sort of old, antiquated. That's not the modern approach. The modern approach is to throw an exception. When your code throws an exception, Java is no longer executing your code. It's now sort of sending up a flag that says to the caller of the method has failed. And it's much more graceful. Let me be more specific. Let's do an example. I've got code here for a method that throws an exception. So you can see the syntax for throwing an exception. You guys are lecture 3. I should be down here. Exception example. Make this window small. All right, I see somebody with a laptop out that should not have a laptop out. I'm not looking at you, but I'm pretty sure you're not supposed to have that out. Put your laptop away. All right, here's a method I'd like to write called get smallest. It takes in a list of integers and returns the smallest integer. Now here's my you can write that. Like if I made this like a test question, find the smallest thing in the array and return it. Doesn't sound that hard. Write a loop, goes through, finds the smallest thing and returns it, right? Okay, no big deal. Here's the thing though, guys. What if the list is empty? What are you going to you have to return an integer. It says so right there. The list is empty. You're supposed to return the smallest element in the list. What are you going to do? This is a perfect case where I would throw an exception in that case for sure. So that's what I've done. Let me show you how that code might look. So it starts off, if the size of this list is 0, forget it. Throw. That's a keyword in Java. After throw, you actually instantiate an exception class. Now these classes are built into the language and you've seen some of them. I'm sure by now you've seen a null pointer exception, probably array index out of bounds exception. Here I'm throwing something called an illegal argument exception. I'm saying whoever passed in this list passed in an illegal list. That argument doesn't make any sense to me. So I'm throwing this illegal argument exception. The constructor for all these exception classes is usually expecting a string where you sort of describe what went wrong. You can make up whatever you want. I wrote empty list, has no smallest element. The purpose of that is for some other programmer who's calling your method. If the exception happens, they can retrieve that string and kind of get an idea of what went wrong. So it's sort of like internal debugging string. Anyway, if the list is size 0, I'm throwing the exception. In a minute, I'm going to draw a picture that shows you guys exactly what happens in Java at the moment an exception gets thrown. But the short version for now is, let's look at the rest of this method, which I think is correct. If the exception is not thrown, then we just do the job. If I can manage this, here we go. So if the exception is not thrown, I actually go through the list, find the smallest thing, and return it. Okay, just like I normally would. But if the exception is thrown, Java's not going to touch any of this code. Let me describe for you with a picture exactly what happens at the moment an exception gets thrown. You guys can see this, right? Okay, cool. So here's the call stack. Main method at the bottom. Let's just pretend that the main method calls another method called f. And then let's pretend the f method calls g. And then let's say the g method calls the one we're looking at right here, get smallest. I guess I'll write it. I'll have the crazy handwriting. Pretend it says get smallest, use your imagination. So we're here in the get smallest method, and usually it works. Usually nothing bad happens, you're returning the smallest thing, you go back here and process it, whatever. But let's pretend we're in that case where somehow this method g passed along an empty list. And so we're going to hit that statement that says throw. And now I want to describe what happens to you. I'm going to use the word handler right now. And for now, I want you to view that as an abstraction. I'll show you the Java syntax for a handler in just a minute. But think a handler is code that sort of deals with the problem. And I'll show you how to do it in a minute. But for now, just accept this word handler. So what Java's going to do first, believe it or not, is it's going to look right here at the place where the exception was thrown to see if a handler is present. And I'll tell you right now, it won't be. But Java's going to check there first. I'll show you what it looks like in a minute. But it's going to look here, there won't be a handler. And so Java says, all right, I'm throwing this frame off the call stack. We're going to go back to the method g, right at the spot where the get smallest method had been called. And I want to emphasize, this code is not running. The method get smallest is over. We're leaving. The exception is thrown. There's no handler here. We're done with this method. We're going back to the point where the method had been called. So now Java's not going to run any code until it finds a handler. Java's going to look here at the spot where get smallest had been called to see if there's a handler there. If there is, it runs the handler, and the problem is solved. I'll show you that in a minute. If there's no handler here, this method is popped off the call stack. Java goes back to the place where G had been called over there in F to see if there's a handler there. If there's a handler there, the handler runs, problem solved. If there's no handler here, same story, this method is popped off. We go back to the main method right at the spot where F had been called to see if there's a handler. If there is, it runs good. If in the main method there's still no handler for this exception, the main method is popped off the stack and your program terminates abruptly. If you happen to be in the Eclipse environment, this is the point where you get that red and blue stack trace in the console. I'm sure you've seen this 1,000 times. I get it every day, right? So you messed up something, an exception gets thrown, Eclipse shows you this red and blue stuff at the bottom. That's what happens if an exception is thrown and it's not called any place. In the back.
And like the string echo method, like
For the what?
like for example, in the string index up method that returns -1 when there's no instances, like that could be an exception, right? Like if there are no instances. So like when you like return a certain value, like in that case, you want to
Yeah, it's up to you. I don't have a sharp answer for you, but when you're writing code, so the downside for throwing and catching exceptions is that it's pretty expensive in terms of CPU cycles. So returning an error code is quick, and that method he's mentioning, index of, it's pretty standard to ask about a thing that's not in there. I don't know that I'd call that an exception, you know? It's sort of like we return a negative one if it's not here, and that's typically the case. You know, that happens pretty often. Exceptions are usually weird. You know, that's the best answer I've got for you. But they could have chosen to implement that with throwing an exception. It wouldn't be wrong. Either way is actually okay. All right, anyway, so let's see, where was I? I talked about this. I lost my train of thought. Okay, so that's right. I ended with, in Eclipse, if the exception is thrown and not handled any place, you get the red and blue stuff at the bottom of the screen. Now, in a finished program, you certainly don't want exceptions to get thrown and not caught, not handled anywhere, because your program's just going to crash, right? So that's not good. All right, I have a lot more to say, but I want to pause for questions. Go ahead, buddy.
Is it more optimal to put a handler in the name or like put a handler in each success amount?
Good question. So if you're calling a method and you're aware that that method might throw an exception and you know how to fix it, fix it. You should try and handle it whenever you can. But it's possible that the find get smallest throws the exception, and whoever's writing this code where my pencil is, maybe it's not clear how to handle it there either. So they just let go. And then it goes down to whoever called them, and there it's sort of the onus is on them. But if you have a way of fixing the problem locally, do it with a handler. I keep saying handler, let's get to it. Here's what in Java a handler looks like. So you may have seen try catch, that's what I meant by handler. So the idea is there's a try block followed by one or more catch blocks. We'll talk about finally later. But it's a try block followed by one or more catch blocks. In the try block, you put the method call or code that might throw an exception. And then you write catch blocks that are your handlers. So when I look at this, I see that the call to the get smallest method might throw a null pointer exception. And that's true. If you look at that code, I said that the list was empty, I threw this thing, but what if this variable list was actually a null? Not an empty list, but there is no list, it's null. Well, I guess you guys probably have seen this. Right there, when you try to use the dot operator on a null reference, Java itself will throw a null pointer exception. Sometimes exceptions are thrown because it says throw. And sometimes the exception is thrown internally. The JVM is like dot operator on a null reference. We're not doing it. Java here is throwing a null pointer exception sometimes. So this method we're looking at could throw two different things. It might throw a null pointer exception. It might throw an illegal argument exception. And I've got catches for both of those guys. That makes sense to me. So the flow is you're running the try block. If one of those exceptions is thrown inside the try block, Java's going to go straight to the corresponding catch. If we're running against smallest and an illegal argument exception is thrown, look at my screen, this dot 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 is not happening. We're not doing that. We're not doing this catch either. If it's an illegal argument exception, we're going straight here. And whatever code appears in that catch block is supposed to help and not help, it's supposed to solve the problem. The catch block is the handler. You know, I don't know how to explain what you put there. You put whatever solves the problem in that context.
Yeah, good question. What
Oh, good, that's not done. So E is a variable that's being declared here. I always say, you know, that's a terrible name for a variable, right? We all do it. Everybody puts E there. When you throw an exception, let's look back at that syntax. It says throw a new something. So we're actually instantiating an object here. There's an actual object being created. E is a reference to that object, believe it or not. So it's literally like throwing something and catching that thing. So we actually have the exception here in scope. Then you might say, well, what can you do with E? Usually nothing important. I never touch it, but you can recover that stack trace. You can also, that message somebody put in about what went wrong, you can recover that and a few other things. Most of us ignore the variable E. You sort of type it in and you never use it. Good question. All right, anyway, so when I see this code, let's ignore finally for now, we'll talk about that in a minute. When I see this code, I think to myself, the usual flow is we do the try block, nothing weird happens, and we just go about our business. The catch blocks are error handling code, so when I'm usually scanning code written by some other person, I just ignore the catch blocks. But if you're curious what happens if something weird transpires, then you can look at the catch blocks to see how those weird things are handled. All right, let me pause and see how you guys are doing, then I'll talk about finally. Yeah?
Can you do something to catch any exception?
You can. I have a slide about that, and I'm gonna put my slide up there and tell you to never do that. So hold on to that thought. I'll talk about that in a minute. Yeah.
Do you have to like specify like the error and like when to throw it, or is there a way like for the method to just be like if there's a problem like in the header to throw the exception, like in the method header?
You might be thinking about the keyword throws. I'm gonna cover that today, but the stuff you said leading up to that, I didn't quite catch. There's a keyword throws that you'll see in a method declaration I'm gonna talk about today. That has to do with something I don't think you've seen before, I don't know. I'm not quite sure what your question is, to be honest. Sort of, yeah, we'll get there. If you wanna just hang on to that, Paul, we'll get there. Yeah.
So going back to Tony, the keyword for throwing exception is throw or throw?
Throws with an S. Yeah, so if you want to throw an exception in your code, you're right, sorry, I said the wrong thing, I said it backwards. If you want to, sorry, somebody was like, are you crazy? Yes, I'm crazy. So let me fix that. If you're trying to throw an exception, you write throw, and then new whatever. Null pointer exception, whatever. But there is a keyword throws with an S that I'm going to talk about in like 10 minutes.
Okay.
All right. So let's see. Finally, that's right. Let me talk about finally. We don't normally see finally. I'd say like 1% of the time we'll see a finally block. It's always at the bottom. It's hard to explain. Actually, it's not hard to explain. I will say it really succinctly. If Java has entered the try block, no matter what goes down, the code in the finally block is going to run. And if you understand that, we can move on with our day. And yet, I'm going to do examples. So let me say it again. As soon as Java enters that try block, crazy stuff could happen. I don't know what the flow is going to be, but the finally block will certainly run. I promise it will run. And now I'm going to do examples to make sure that you're really clear on that. So, first example is like the normal flow of the program. Java starts the try block. Nothing weird happens. You do the whole try block. Catch blocks are error handling. We're not going to talk about that, but before we proceed with the rest of this program, we're going to run the finally block in that case, followed by the rest of the program. So the finally block runs in cases where there are no exceptions thrown. I saw your hand up. What's up?
Yeah, I was gonna ask, what if one of the exceptions isn't in there? Will the finally block still run?
Yes, that's my third example. And that's one of the surprising ones. We'll get to that one. My second example is we're running the try block and an exception is thrown that I'm anticipating, like illegal argument exception, let's say. So you're in the try block, you call get smallest, illegal argument exception is thrown. Okay, I get it. We come straight to the catch block, we do whatever's there, it handles the problem. Then the finally block runs, and then we proceed with the rest of the program down here when they arrows. So that's pretty normal also. Now this flow is a little bit weird. What if we're in the try block, an exception is thrown, and I'm not catching it? I'm not handling it. It's like an arithmetic exception or something weird, IO exception, whatever. I'm not handling it. Now I told you guys, here we are, presumably A and G here, and there's no handler for the exception that's pending. Like I said, this method is going to get popped off the call stack, and we're going to go down to the place that called the method we're looking at and see if there's a handler there. In other words, we're leaving the method abruptly. On the way out, believe it or not, the code in the finally block actually does run. When I first heard that, I was skeptical, and I tried it out. Sure enough, it works. In 131, I do an example like that because I have time in that course. All right, anyway, the finally block does run if an exception is thrown and not handled here. On the way out, the finally block runs. Another similar weird case, it's worth mentioning, what if there's a return statement? Maybe in the try block there's a return statement, or perhaps in one of the catch blocks there's a return statement. And I think you guys know when you execute a return statement, the current method is over. It's very abrupt. Return means method over, leave. And you go back to the place where the method had been called. Believe it or not, on the way out, the finally block will still run. So it's sort of like, whatever you do, if you've entered the try block, you're guaranteed that the code in the finally block is going to happen no matter what crazy stuff goes down. What's the purpose of the finally block? It's usually something that you'd say is sort of like mission critical. Usually the try block involves maybe like setting up some kind of data structure, and something weird happens, it gets interrupted midstream, and so the data structure is malformed. The finally block is likely to either undo it all or make it a well-formed structure. It's sort of like closing up loose ends that may have gotten interrupted somehow in a bad way. Anyway, we don't see it very often. Yeah?
If you return something and then the finally block runs, can the finally block also return something?
That's an interesting question. I'm smiling because it's funny that you're the second person to ask me that today. It's such a weird little case. I'm surprised you guys thought of it, but that's possible. I'd call that a paradox. What if we're in the try and there's like return 7? And I just said the finally block is going to run, and the finally block says return 12. This guy's like, well, what do you return? That's actually specified. I know the answer. I'm going to tell you to Google it. Another funny comment, that was actually a job interview question a friend of mine saw at a job interview. We both laughed because it's so ridiculous. Like, is that really like part of Java programming to know that weird, So it's an interesting question. It's paradoxical, but it's not too important. The other paradox that sometimes students ask me about is an exception gets thrown, and then we're not catching it here. It's like some other weird exception we're not catching. We are running the finally block. What if another exception is also thrown in the finally block? So there's like 2 pending exceptions. Well, that's even weirder. I don't know the answer to that. I have no idea. That should never happen. Let's just say that. All right, so don't do that. All right, anyway, let me move forward, I guess. Let's see, okay. So how are we doing? You guys okay? So let me summarize the important stuff I said so far. If you're writing a method and you encounter a situation and it's not clear how to do your job, probably you should throw an exception. When someone calls a method and it's possible that method might throw exceptions sometimes, that person probably ought to wrap that method call in a try and put in an appropriate catch to fix that problem. If they can't and they ignore it, then it's going to propagate to the caller of their method and the onus is on them to try and handle it and so on. All right, that's what I said so far. Here's a diagram. You do not need to memorize this. I just want to show you. These are some of the exceptions that are built into Java, some of the classes that represent exceptions. Look on the right-hand side of these blue ones over here. You've probably seen most of those, right? Like there's stuff up here. Again, I see people with laptops out that didn't talk to me in advance about having laptops out. Guys, laptops are not allowed in class unless you have pre-authorization from the University of Maryland. I shouldn't have to repeat that 6 times. Then you shouldn't be in my room. I'm sorry, I gotta ask you to go. We're not allowed to have people attend class who aren't registered. I'm sorry. All right, so anyway, you've probably encountered these blue ones before. Look at those guys, like null pointer exception. I get those every day. I put concurrent modification exception up here. We talked about that one in class. The ones that are in blue are things that honestly are encountered because usually you made a mistake in your code. You know, like what's up here? Array index out of bounds exception. Actually, I think this should say array index out of bounds exception. But anyway, you know, that happens because you screwed up. You made an array of size 10, and somehow in your code you're trying to access box number 15. Yeah, it's going to throw an exception. You better fix your code, right? So these blue ones are things that are sort of not supposed to be happening. It usually means there's a bug in the code when I see those. Now the yellow ones are things that actually are expected to happen routinely, even though your code is finished. Like my first example, I said we're trying to write code that connects to a website and reads some data off a website and does some kind of computation. If the internet is down, there's nothing I can do about that. No matter how good my code is, I can't fix that. That would be an I/O exception, yellow. The yellow ones are things that are common, and it's not that your code is broken, it's just there's something beyond your control, you can't do your job. So there's a big distinction here. The blue ones are called unchecked exceptions, the yellow ones are called checked exceptions. And this is a feature in Java that I need to explain more. All right, let's talk about these checked exceptions. Let me go to my slides so I don't forget what to say. I'm getting tired. So the blue ones are the unchecked exceptions. These are things that really mean your program is broken. You shouldn't be seeing this. You've written poor code. You wouldn't normally write a try catch for one of those blue ones. You know, let's say, look at my slide for a second. Let's say here's your statement. You got this array A, and somehow this statement is throwing an array index out of bounds exception. Are you going to wrap it in a try and put a catch in there for array index out of bounds exception? No. That means fix your code, right? So those blue ones, the unchecked exceptions, are not normally handled. You don't usually write a catch block for those. It means your code is to fix your code. You can. I'm not saying you'll never see it, but it'd be very unusual to see a catch block for something that's one of those blue unchecked exceptions. Now the yellow ones, checked exceptions, represent things that really can happen. Even if your code is finished, those things can happen. Your code is correct. It could still be the case that you get an I/O exception or something like that. So you should be writing catch blocks for those pretty much every time. You're calling a method, it might throw an I/O exception. You have to decide what's going to happen in that case. In my project, what will happen if I can't connect to the internet or the file isn't there that I'm looking for or something like that. So we usually see try catch with those yellow checked exceptions. Believe it or not, Java's going to make you do it. So this is really hard to explain, but you're calling a method, let's say, and the method can throw one of those yellow checked exceptions. The lingo that programmers use is this. They say Java will make you either catch or declare at that point. Let me say what that means. Catch means write a try catch, and that's usually what you want to do. So you're calling a method, you know that method might throw a checked exception, like perhaps I/O exception. You probably should turn around and put that in a try and write a good catch that takes care of the situation where the file wasn't there, or the internet is down, or whatever it is. That's what we usually do. But it's possible that your method may not, locally there may not be an obvious solution, and you're saying, well, I'm just going to let it propagate to the caller of my method. You can do that, but then you must declare. And this is where the throws syntax comes in that people were asking about previously. I'll show you the syntax in just a second. Actually, let's do it right this second. With an example. All right, here's a program that The job of this program is, I wrote a static method called print file. You give it the name of a file, and I'll show you the code in a second. It hooks into that file, reads the text out of the file, and prints it on the console. I'm not expecting you to know how to do that. We're gonna learn it later this semester. But let me show you the code. It's just, it'll be kind of an abstraction, but that's okay. And then we'll talk about the exception handling that's actually relevant here. So here's this method called print file. You give it a file name, and you're not expected to know this yet. We'll talk about it later, but you can create a file object, give it a file name. The file name is like a path on your hard drive. That makes a file object. That's one thing you can do. I've chosen to make a scanner that wraps that file object. I'm guessing you've probably seen Scanner because we tend to use it in beginner courses. The scanner is a thing that reads text from a stream. You can connect the scanner to a file and then read text out of the file. And the API is really simple. So the scanner implements the iterator interface, so I can treat the scanner like an iterator, and in particular I can use has next. So here's my code. I've got a file based on this file name. I made this thing called a scanner that's hooked to that file, and now I'm saying as long as we haven't gone through the whole file yet, get me a line of text and print it. So this loop's going to print lines of text from the file. When we reach the end of the file, has next will become false. So you don't need to know any of this. Guys, this may look confusing and foreign to you. It's okay. All I care about right now is exception handling. So this code is correct. It looks good to me. But see that red squiggle under the constructor for the scanner? There's a red mark there. Guess what? That constructor throws a checked exception. And you can kind of guess what's going on. I'm trying to connect the scanner to a file. What if the file's not there? The person that wrote the scanner is like, I have no idea what to do if the file's not there. I'm going to throw this exception. If I hover over that red mark, then it says, unhandled exception, type file not found exception. File not found exception is one of those yellow ones. This is a checked exception. I have no choice. I can't ignore it. I'm not allowed to just let it go. I have to either do a try catch or do declare. And I'll show you that in just a second. So usually, you say, well, gosh, that's not good. Let me declare the variable and then do the assignment down here. So you'll see why in a second. But I'm going to wrap this in a try. And then put the catch for null, file not found exception. The hardest part is typing it. And put some code in. I don't know what code to write. It's not the point of my lecture right this second, but this works. And now you can see my project is compiling. What should go on the catch block is some reasonable code that handles this issue. I don't know what to do. What am I doing? Print file? It's void return type? I honestly don't know what to do, but pretend you put some code there that handles the exception. That's one choice. So again, the constructor to the scanner throws a checked exception. You have two options, catch or declare. This is what we mean by catch. Wrap it in a try catch, handle it. If you can't handle it locally because you're not sure how to do it, you're allowed to let it propagate to the caller of your method, but then you have to declare. What do we mean by declare? Right here, you type throws, followed by the type of exception that your method might throw. Bet some of you have seen that and didn't know what was going on there. So this means, yeah, I get it. This scanner may throw a file not found exception. I don't know how to handle it here. So I'm going to declare that my method called print file now may throw this checked exception. You can do that. It's a choice. Either do the try catch or declare that your method throws it. But now, the onus is on the person that called this method. I've declared that my method throws this checked exception. Look above. See, here's that method called the method we just discussed. It's now a red mark, and now the onus is here. Now here, I have to do the either try catch or declare that this method throws the exception. Since print file says I throw a checked exception, anytime you call print file, now you have to either do the catch or declare. So I could put a try catch here, or I could declare that the main method throws it, which is odd, but I'll do it so it's quicker. Oh gosh, what did I do there? Control Z. The hardest part of teaching is typing. All right. I spelled it wrong. Something throws, file not found, exception. Left out a whole word. Sorry. All right. So now my program is compiling. So summary of the last part of this lecture. You're calling a method, and the method might throw a checked exception. You have two choices, catch or declare. You can wrap the method call in a try and put a handler in there that deals with it. Or if it's not clear how to deal with it, it should be rare, but if it's not clear how to deal with it, you can declare that your method throws the checked exception. And then the caller of your method has to do the same thing. It's like a chain. All right, so that's the end of that piece. Yeah.
Can your method throw multiple check exceptions, or if you declare it and you declare multiple?
Yes, so it's possible to write throws A, comma B, comma C, just put some commas, absolutely. Let me talk about a couple other quick matters, then we'll call it a day. I'm a little bit behind, but I think I'm good. So this example is supposed to be funny. This is not wrong. Look at this and see if you can unravel what it does. To me, it's funny. You might not think it's funny, but I think it's funny. Right, like it's not wrong. So what does it do? Apparently there's an array called A. We start off with I is 0. While true is a loop that keeps going forever, right? While true, it's always true. And then it says in the try block, print out A element 0. And by the way, increment that variable I up to a 1. No exception is likely to happen at that point, so we go back up and do it again. So it prints out element 1 and bumps up the index to 2. And so it's printing out the elements of the array one by one. It looks pretty good. And then, what happens when you get past the end of the array? Well, where it says A with the square brackets, that's going to throw an array index out of bounds exception for sure. No problem. I'll catch it and break out of the loop. So it's funny because it's ridiculous. This works perfect. This code correctly prints an array. This is correct code to print an array. Now, I don't know about you guys, but I would tend to write a for loop for that just prints the array like a normal person. But you could do this. It's not broken. Would you write this code? I hope not. The reason it's crazy is because throwing and catching exceptions is very expensive. There's a lot of stuff happening behind the scenes. All this stuff that happens with the stack and things in the virtual machine that I don't even have time to talk about, but it takes a lot of CPU cycles to throw and catch exceptions. It's way, 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 way faster to just write normal looping. So in general, please don't use exception handling to handle like normal flow of your program. It really should be something exceptional or weird has happened. It shouldn't be like an everyday thing. Maybe that guy in the back asked me about the method in the string class. Maybe that's a better answer. It's sort of like a normal thing to have to search for something that's not found. It's not really exceptional, So anyway, here's another thing that I consider a bad practice. Somebody has a try block, I wrote something complicated, and I'm imagining that something complicated could throw all kinds of weird exceptions. And maybe this programmer's a beginner and they're like, well, I don't know what kind of exceptions it's going to throw, so I'm going to do this. I don't know if you remember this. Throwable was at the very top of the diagram of all the different exception classes. That means that every exception class there is a subclass of throwable. So this variable E here is really polymorphic. It could be any of the exception classes. So this is what somebody over here was asking me. This is how you could catch anything. And so this code says, we're running this method, I don't know what's going to happen, but if something weird happens, I'm just going to print some message on the screen and call it a day. Please don't ever do that. If you're running a catch block, it should be that there's a specific situation that you're thinking about and you know how to handle it and you're writing correct code that handles it. We don't want to intercept exceptions, especially those blue ones, where the exception indicates your code is broken. You certainly kind of want to know that your code is broken, so you don't want to do something like that. Yeah?
What would happen if you catch an out of memory error or stack overflow?
Catch what now?
An out of memory error or stack overflow.
I don't know. Yeah. Out of memory, that you'd think that it would just sort of die. Yeah, I don't know. I've never seen that. Yeah.
Is there like
Oh, Stack Overflow, I'm sorry to take over, but I just remembered Stack Overflow I see every once in a while. You wouldn't try to catch it. That's one again where like, what are you going to do? I mean, I guess you would try to catch it. If you were writing a method that calls a recursive method and that happened, you probably should catch that and do something. Yeah, anyway, what were you going to say?
Is there like something like throwable that only for
Yes. So this is not testable material. I'm just telling you this in case you care. Sometimes you might want to write your own exception class. I've done it a couple times. And you can choose whether your exception should be a checked exception or an unchecked exception based on what you've extended. So top one, if I write this illegal fish position exception extending runtime exception, Java's going to treat that as a blue unchecked exception. If I write an exception like network too slow exception that extends the exception class, Java's going to treat that as a checked exception. And I forgot what your question was, but